Welcome back. This is Mrs. Rubright with Advanced Geometry. Today's lesson is 4-6. Prove triangles congruent by angle, side, angle, and angle, angle, side. So you were supposed to already copy the for-your notebooks on page 247 and 250. Alright, so identify congruent triangles. Can the triangles be proven congruent with the information given in the diagram? If so, state the postulate or theorem you would use. So on A, we have... I'm going to darken these. There's an arc mark here and an arc mark here, so we know those angles are equal. There's a tick mark here and here, so we know that those are equal. So far we have a side and an angle. Is there anything else that we know in the diagram that is not already marked? Yes. Vertical angles. Vertical angles are congruent, right? If two lines intersect, the angles opposite each other are vertical angles. They are congruent. So right now we have angle, angle, side. So angle, angle, side does prove congruence. Okay, so yes, these are congruent by angle, angle, side. Okay, so we added in the vertical angles. Angle, angle, side congruence theorem. Over here, how about these two? What do we have? We have angle, angle, angle. Does angle, angle, angle prove congruence? No. Angle, angle, angle does not prove congruence. Think about this. If I had a 30, 60, 90 triangle, it could be tiny, or it could have a very large 30, 60, 90. Right? Maybe this one has side lengths of, so maybe this is like 1, 2, and square root of 3, or maybe this one is 3, 6, and 3 rad 3. Right? So they're two different sizes of the same angles. So we cannot prove congruence based on angle, angle, angle. How about on C? What do we have on C? So far we have angle, and we have another angle. Alright, so look at these two. These are alternate interior angles. If alternate interior angles are congruent, then the lines are parallel, right? Alternate interior angles converse. If alternate interior angles are congruent, then the lines are parallel. So these are parallel, so we have a parallelogram here. What else do we know? We know that this is a shared side, so reflexive property in it. So we would have angle, side, angle. The side is the included side between the two angles, right? We have this angle, we have this included side, and this angle. So this is angle, side, angle. It has to be sandwiched. The side has to be sandwiched between the two angles. It has to be the included side. Just like when we did side, angle, side, the angle had to be the included angle. It had to be a sandwich, okay? So, prove the angle, angle, side congruence theorem. Write a proof. So this is what we're given. This is called a flow proof. So far we have done a 2-column proof. We've done a paragraph proof. Now this is a flow proof. So a flow proof is literally going to go from top to bottom or from left to right. So either way. So we list our givens and we write that they are given. Okay? So I'm going to mark things as I see them. So right here, given, angle A is congruent to angle D. A and D. Angle C is congruent to angle F. C and F. Segment BC is congruent to segment EF. BC is congruent to EF. So I marked the 3 givens that were given. So now, what's next? We did that. We're trying to prove that the triangles are congruent. So what do we have so far? We have angle, angle, side. Right? Does angle, angle, side prove congruence? Yes. But we're trying to prove angle, angle, side, so we can't use it. We have to use something else other than angle, angle, side. Right? Because you can't use what you're trying to prove itself. So the only other thing when I'm staring at these diagrams, the only other thing that I know is that angle B is congruent to angle E, and the only reason I know that is because of third angles theorem. If two angles are equal, then their third angles are equal. Right? So I know this because of third angles theorem. So why they have 2 arrows going here is because since the 2 angles are equal, then their third angles are equal. So that leads to here. Okay? So this proves a angle, right? We already had a side. And then these are both angles. So what are we using for our answer? We're using an angle, and a side. So BE, let's see which ones we're using now. So we're using the third angles. We're using this. We're using C and F. And we're using these sides. So what are those? That's angle, side, angle. Do you guys see that? Angle, side, angle. I'm using an angle, I'm using a side, and I'm using an angle, and the side is sandwiched between the two angles. This is angle, side, angle, right? I can't use AAS because that's what I'm trying to prove that that works. In the diagram at the right, what postulate or theorem can you use to prove that the triangles are congruent? Explain. All right, so we have the triangle angle S is congruent to angle U. That was what? Given. It's given in the diagram, right? We also have that RS is congruent to UV, okay? Or actually, RS is congruent to VU, right? We're listing them in corresponding positions, which they didn't do because they're not that great at that, but that was also given. Then, what do we know? We know that vertical angles are congruent, right? Angle RTS is congruent to angle VTU. Why? Vertical angles. So now we have angle, angle, side. They are congruent by angle, angle, side. Make sense? Another flow proof. Alright, so we have this given, and we are going to write it as a given. So they wrote it over here. So this one's going from top to bottom. Okay? So CE is perpendicular to BD. Well, if it's perpendicular, then we know that these are 90 degrees. That's what we know. Definition of perpendicular, right? Okay, if they're perpendicular, if they're 90 degrees, they're equal to each other. We know all that based on that one given, right? That given leads you to here, which leads you to them being equal, right? So now, let's look at another piece of information. They gave this given. CAB, right here, is congruent to CAD. That's given, right? What are we trying to prove? We're trying to prove ABE, this triangle, is congruent to ADE, to this triangle. So what do we know? Well, I know that this right here is reflexive, right? AE is congruent to AE, reflexive. So that's a side. This was an angle, right? We need one more piece of information. So, based on this, if these two are equal, then their linear pairs are equal, right? So then this is equal to this. Congruent supplements theorem. Congruent supplements theorem says if they're a linear pair and they have an equal, like if one of their angles is the same on a linear pair, then they're equal to each other. So that is an angle. So we have angle, side, angle. Angle, side, angle. Make sense? Alright. Fire towers. The forestry services use fire tower lookouts to watch for forest fires. When the lookouts spot a fire, they measure the angle of their view and radio a dispatcher. The dispatcher then uses the angles to locate the fire. How many lookouts are needed to locate a fire? What do you guys think? How many lookouts do you think you need to locate a fire? 1, 2, 3, or you don't have enough information? What do you think? What do you think? You're going to triangulate its location, you need two lookouts. The phi is the third point. Does that make sense? If you have two lookouts, you could triangulate its location. Okay, so it's B. 2. Have you ever heard the term triangulate its location? Yeah. Some of you? Alright. And that was everything on your first lesson, which was 4.6, Prove Triangles Congruent by Angle, Side, Angle, and Angle, Angle, Side. I hope you guys enjoyed this lesson. Please like and subscribe, and have a great day.